Hello and welcome, dear students. Today we are going to nourish your minds with useful information to improve your mathematical skills. This video is for grade 9 mathematics. In this video presentation, I will be guiding you in the first module for the first quarter of our subject mathematics for the grade 9 level. The topic is quadratic equation. Specifically, topic 1 or lesson 1 of this module is all about the introduction to quadratic equation. What you need to know. At the end of this lesson, you are expected to illustrate and identify quadratic equations. Second, write quadratic equations in standard form and determine the components of quadratic equation. What's in? Currently, you're a grade 9 student, right? Now let's recall and let's go back in time as we revisit your grade 8. Let's recall your past lesson in the first quarter. You were taught how to get the products of various polynomials and to get the special products. Let's recall each. For example, letter A, product of a binomial. Now let's recall how to use FOIL method. So for example, you're given two binomials and multiplying A plus B to the quantity of A plus C. Let's identify the first terms, followed by the outer terms, that's A and C. We also have inner terms, that's B and A, pointed on the screen right now. Then we also have here the last terms, that's B and C. So that is your FOIL. First, outer, inner, and last. So how do we get the answer or the product of this one? The result will be the product of the first terms, that's A multiplied to A, giving you A squared. Okay? Then add it to the product of your outer terms. That is your A multiplied to C, therefore you have AC. Now, we have here the third term, that's plus AB. Where did we get AB? That is the result of your inner terms. B times A, and having it alphabetically, that is AB. Plus, the last term is coming from the last terms of our two binomials, which is B and C. So this is now our answer, A squared plus AC plus AB plus BC. Now, there's another pattern for this. Now, let's have an example using the FOIL method. For example, we have here the quantity of x plus 2 multiplied to the quantity of x plus 5. So we are going to get the first terms, the product of the first terms, that's x multiplied to x for our f. Followed by our outer terms, that's x and 5. Then we also have our inner terms, that's 2 and x. Then our last terms are 2 and 5. So following the FOIL method. To get the answer, we are going to multiply or get the product of each terms. So for the first terms, the outer terms, the inner terms, and the last terms. So look at my laser pointer. For the first one, that is x multiplied to x, will give you x squared. Add it to the next product, that is the outer terms. That's x and 5. So that will give you, yes, correct, that's 5x. Then for the inner terms, that's 2 and x. So the answer is, good, that's 2x. And finally, our last terms are 2 and 5. So what's the product of 2 and 5? Nice, that's 10. So the final answer here is, actually the answer using the FOIL method is, let's see, and let's compare. So you have your x squared plus 5x plus 2x plus 10. Now observe that at the center, you still have two terms having similar terms. You have there two terms with a variable x. So what do you need to do here is, okay, you need to add similar terms. So the result now is x squared plus 7x plus 10x plus 10. Since you added 5x and 2x right here, giving you 7x for the middle term. So the final answer is a trinomial, which is x squared plus 7x plus 10. That is correct. So that's how you use FOIL method. Just a review. Now this time, how do we use patterns to get the product of binomials? Say for example, the same set, we have here quantity of a plus b multiplied to the quantity of a plus c. So we can follow this pattern. Square the first term a, so we have a squared. Next, we have here add it to the product of a and the sum of b and c. So add first b and c, then multiply it to letter a. Then the last term is the product of b and c. So that will be for the pattern. So how do we use that? For example, x plus 2 multiplied to x plus 5, same example for the FOIL method. So here, I'll use my laser pointer. Observe, first terms are x, so that will give you x squared, following the pattern as shown above. Here, we have b plus c, so our b here is 2, our c is 5. So get the sum, 2 plus 5, 7. Multiply it with a. Our a in this example is x, so that was 7, right? 7 times x will give you 7x. And our last term is the product of b and c. So we have b as 2 and c as 5. So the product of 2 and 5 is 10. So that will give you 10. So the answer is x squared plus 7x plus 10, having the same result when we use the FOIL method. So that's it for the first pattern. Correct. Now, how about for the square of a binomial? Your binomial in this example is a plus b, and you're getting the square of that. So to get that, we can use this pattern. Square the first term and add it to twice the product of a and b. Then the last term will now be the square of your given binomial. I mean, square of the last term of your given binomial. So that will be the pattern. A squared plus twice the product of a and b plus the square of b. Example. We have here x plus 2, or quantity of x plus 2 squared. So we will follow the pattern. It will give us a squared, which is x squared, since our a here is x and our b is 2. So x squared plus, how did we get 4x? We have here multiply a and b, then double it. So you have x times 2, that will give you 2x, then double it, it will give you 4x. Plus, the last term here is the square of your b. So our b is 2, so the square of 2 is 4, thus giving us this trinomial, x squared plus 4x plus 4. That's it. Very good. The next is cube of a binomial. This would be the next on our list for the special products. How do we get this? Now, let's try to recall the pattern. So we can get the value of this one, the cube of our a plus b, by cubing the first term, that's a cubed, plus 3 times the square of the first term multiplied to the second term. So that's 3a squared times b, followed by 3, and then copy a, then square the second term b. Then our last term for this polynomial is, the result is more than 3. So it's not a trinomial unlike the previous example. So here is a polynomial with 4 terms. So our final term, or the last term, is the cube of the second term. So we have b cubed. So this is now the pattern for cubing a binomial. So the next part and the last pattern that we are going to tackle and review is sum and difference of two squares. So let's have here a plus b, the quantity of a plus b, multiplied to the quantity of a minus b. So how do we get the product? It's a special product. The pattern is square the first term like this, a squared, minus square the second term. That's it. You will get the square of b, so the answer is minus b squared. Like that. So that will be the pattern for this special product. Let's have an example. Let's say you're given the quantity of x plus 3 and you're going to multiply that to the quantity of x minus 3. Now, it follows the same pattern as what we have earlier. Now, how do we get the answer for this? We are going to square the first term, giving us x squared, like this, minus the square of the second term, which is 3. So that will give us 9. So the answer here is x squared minus 9. That's correct. So what's new for us? Now on the screen right now, you can see here 6 questions. So this time, I want you to get that and try to answer and get the product of the following binomials shown on the screen. Now to help you out, I prepared here the table that summarizes our special products and the result using the patterns to get the result. So do not forget to pause this video and take your time. You have there 6 items. Okay? Are we clear? Again, pause the video and you can play it once you are ready to confirm your answers. Now let's do this. You can pause the video now. Okay, are you done? Alright. Let's have guide questions first. I know you have already the answers on your notebook or on your paper. So based on the answers, before revealing the complete answer, the solutions. Now, what have you observed with each resulting product? Did it have the same number of terms? And which of the following products have the same number of terms? Now let's answer that by showing to everyone the solution in this table form. So this is the result showing this table with 3 columns, wherein our first column shows the given, the method for the second, the method and how to get the answer, and finally on our last column it shows the result. Now, what do you observe? Do all the results show the same number of terms? Observe that there are answers inside the red box. What are the similarities? Good. So these terms, or I mean these answers inside the red box shows 3 terms, right? The result is a trinomial. While on number 4, we have here a binomial and we have a multinomial for number 6. Now, which of the products have the same number of terms? That will be numbers 1, 2, 3, and number 5. Number 4 is a binomial and number 6 is a multinomial. I hope that's clear. Now this time, what we need to do is to focus on the results inside the red box. Now let's focus our attention for that 4 results. Now observe that this one shows the following components. Look at the first part, the first term of the trinomials. So what do you observe? It follows ax squared, wherein your first term is considered as a quadratic term. The highest degree is 2 of your variable. So here, the highest degree for the first term of the first answer is y squared. That's y with the variable y with the degree of 2. Same with the second, third, and fourth. They differ with the variable. Second is r, third variable is x, and here for our last example, the variable is z. Now, what do you mean by a? A here represents the numerical coefficient of your x squared. So here, our y squared has the numerical coefficient of 1, so that will be a is equal to 1. Same here for the second one, pointed by my laser arrow, my laser pointer. So I have here 1 for a. Then here, the numerical coefficient of x squared is 2, therefore your a is equal to 2. And for the last example, our a here is 1. Okay, that's clear. Now, I hope that's clear. So this time, let's focus on the second set. That means we are going to look at the second term or each of the second term of our examples. Now, it follows this format. It's bx, where your b is the coefficient of your x. That's your second term and is a linear term, since the degree of this will be 1. Okay, so here our bx is 7y, the value of b is 7 with a variable y. In the second example, it's minus r. So our b is, take note, it's negative 1 since it has here negative. So again, the value of our b is negative 1 with a variable r. The third example here is negative 5x. So our b is negative 5 with a variable x. And our final example here is 8z. Our b is correct, that's 8, and with a variable z. So again, this is our second term, and it's a linear term, meaning the highest degree is 1. Okay, now, let's move on with our third set, that is looking at the last terms. So here, we are going to have c. What does it mean when we have c? Now, it's our third term, and c represents the constant number or the constant of our expression. So here, in this expression, look at this. This will be our value for c. That's negative 12. Here, it's still the same, negative 12. And in the third example, our constant is positive 2. And in the final example, our letter c or constant is positive 16. So these are the three properties, the properties that we have to make it a quadratic equation. Take note that it has the first term, which is a quadratic term, the middle term or the second term as a linear term, and we have here the last term of our trinomial, which is our constant represented by letter c. Okay, speaking of quadratic equation, now what do we mean by that? Quadratic equation it's a polynomial equation in one variable expressed in the form ax squared plus bx plus c is equal to 0. Take note that we already have earlier the three properties being mentioned, that it consists of the quadratic term. Here it is your ax squared, your middle term, which is your bx, which is a linear term, and our last term here is letter c, which is our constant. Take note, a, b, and c are real numbers. A, b, and c are real numbers. These are numerical coefficients of the different parts of our quadratic equations. Letter c, by the way, is the constant. And another thing that you need to remember, that in this quadratic equation, the value of our a must not be equal to 0. Okay. Now this quadratic equation, with the first term as ax squared, notice that our exponent there is 2. That's why quadratic equation is also termed as a second degree equation. Again, because the highest degree is 2. Now, how about for going back to example number 4? Remember that we have here m squared minus 36 using the special product for sum and difference of two binomials. Now, earlier we mentioned that there are three properties, right? The three parts of your quadratic equation. Now, how about for m squared minus 36? Is that considered as a quadratic equation? What do you think? The answer for that is yes. It's still a quadratic equation. Why? Because it has the first term, which is a quadratic term, wherein your first term here is m squared. You do have your middle term, but the value of your b is equal to 0. So that will now be 0m. And your constant is negative 36. So again, for clarification, we have here these values for our a, which is 1, our b equal to 0, and our letter c equals negative 36. Do you understand? Well, that's great. And now I want you to try this. Identify which of the following equations are quadratic. Keep in mind that this is the form of your quadratic equation, with its first term as a quadratic term, its second term as a linear term, and your last term here is a constant. Now let's write these items. Number 1, x squared plus 5x is equal to 24. Second, 8x squared minus 8 is equal to 0. Third item is x minus 3y squared is equal to 0. Number 4, square root of x plus 4 is equal to 7. And our last item, number 5, is x over x plus 2 is equal to 1 over x. So we have 5 items. You may pause this video and identify carefully if these items are considered as quadratic equations. Take your time. Again, pause and take your time. Go ahead. You're done. Now this time, let's reveal the answers. So here, let's confirm if what you have identified earlier is true or not. So let's confirm if these are quadratic equations or not. So we have here the 5 items, right? So let's have the first one. X squared plus 5x is equal to 24. Is that quadratic? Again, is that a quadratic equation? Let's see. That is a quadratic equation. Very good. Why is this a quadratic equation? Even though at the left side, it only consists of 2 terms, and the other one, or the right side, is not equal to 0. Now let's see. It's a quadratic equation since the given equation is in the highest degree of 2 right here, and the terms are complete. Now, if you're going to use addition property of equality in both sides, adding negative 24 to the left and right side of the equation, it will give you x squared plus 5x minus 24 is equal to 0, following the form of your quadratic equation. And again, the degree is 2, confirming that it's really a quadratic equation. So if you got it right, tap your shoulders and say, good job. So that's it. Good job for the first item. Now how about for the second item? 8x squared minus 8 is equal to 0. Is that a quadratic equation or not? That is still a quadratic equation. Why? Since it contains the quadratic term. Similar to example number 4 that we've explained earlier, even though it only consists of the first and the last term, but still, it's a quadratic equation. Since it contains the quadratic term, and the middle term here is 0x, where your b is 0, and your variable is still x. Okay, do you understand? Good. Now here, how about for the third item? That is not a quadratic equation. Why? Because it contains 2 variables. You have here, take note, the first term is x and your second term is y. Even though the highest degree is 2, but take note that for your this would be your first term, right? Because our arrangement here is from highest degree to the degree and then following the decreasing order. So highest degree, first term, second, but take note the variables are not the same. So it must have the same variable to consider it as a quadratic equation with the highest degree of 2. That's why this number 3 or this item is not a quadratic equation. How about for number 4? Let's confirm your answer. This is still not a quadratic equation, because there's no quadratic term, rather it contains the rational exponent, which is 1/2 for this square root of x. Now, how about for item number 5? Do you think this is a quadratic? What do you think? Is this a quadratic equation or not a quadratic equation? Let's reveal. The answer is this is a quadratic equation, because using proportion, it could give us the equation x squared minus x minus 2 is equal to 0, following the form of your quadratic equation with the first term as the quadratic term, the middle term, and your last term, which is a constant. So that's it. 1, 2, and 3 are quadratic equations, while numbers 3 and 4 are not quadratic equations. So I hope this one is clear now, and you've done a very good job if you're able to have all the answers correctly. Fantastic work, grade 9 student. Well done. Now this time, let's have the second part of your task, and that is this one. Looking at our 5 equations, your task here are as follows. Number 1, you're going to write the following in standard form using this. This is the standard form of your quadratic equation. Now, I'll be using my laser pointer for clarification. Follow this right now. Here, this one. I'm pointing it right now. So this one. Second task is you're going to identify the quadratic, the linear, and the constant term of each equation. Remember the first, the second or the middle term, and the last term of your trinomial. And your last task is you will identify the values of A, B, and C. So again, you have three tasks. The first one is to write it in standard form. The second one is to identify the quadratic, linear, and constant term. And the last one is you're going to identify the values of A, B, and C. Okay, so I hope that's clear now. So this is now our solution in this table form. So let's try to have a look at our first item. So right here, I'll be using my laser pointer so that you can follow. So this was the given, and using symmetric property of equality, then we can have this equation. Now from this, we can get our quadratic term, which is 9x squared, our linear term, which is negative 9x, and our constant is negative 28 with these values of A, B, and C. Okay, so how about for the second item? So inside this red box right here. So this was the given, and it's already in standard form of our quadratic equation, so it's easier for us to determine the different parts. So 7x squared is our quadratic term, followed by negative 6x as our linear term, and our constant will be negative 20 with these values of our A, B, and C. Okay, that's good. Now, moving on, our third item is this. Now, observe that there are only two terms. Unlike our previous examples wherein the middle term is missing or there's no value for our middle term, but right now we do have our middle term. So from here, we can have x squared as our quadratic term, our linear term is a negative 3x, but this time our constant is 0. So with these values of A, B, and C. Okay, now for our fourth one, this fourth item, here we still have negative 4 that needs to be multiplied to the quantity of 2 plus x. So based on the given, we need to apply our different properties of equality like distributive property of equality and addition property of equality to have this sign of our solution, which is now x squared minus 8 that is coming from here minus 4x that is still coming from negative 4 times x minus 13, that's using the addition property of equality, so we have this line. After that, we are going to add like terms, thus our answer here is x squared minus 4x minus 21 is equal to 0. This will now be our basis to get our components or different parts of our terms. So this would be our quadratic term, x squared, negative 4x is our middle term, and our constant is negative 21. So with these values of A, B, and C. Now finally, our last item here is this one. So we have your last item for number 5. So same procedure for number 4, wherein we are going to apply different properties of equality to end up with our quadratic equation in this standard form. So we need to use distributive property of equality. At the same time, we will be using addition property of equality and symmetric property of equality. So here we have 6 minus 6x coming from here plus 2, then copy the right side of the equation. Now, what we did in this part is we have addition property of equality, thus we have everything on the right side of our equation. So we have here 3x squared plus 6x minus 17 minus 2 minus 6. Now, combining like terms, we'll have 3x squared plus 6x minus 25. Now, to make it in standard form, you'll be using symmetric property of equality. Thus, we have 3x squared plus 6x minus 25 is equal to 0. So it's easier for us now to identify the quadratic term, which is 3x squared, our linear term 6x, and our constant term negative 25 with these values of A, B, and C. So that's it. Those are the answers for our 5 items for the different quadratic equations. So I hope you're able to get it. So again, you can go back to that part of the video that you find that you just need clarifications or you can revisit to attain mastery. So what's more, I prepared here a seat work for you to work on to assess if you've learned our topic or to assess your understanding on our topic for today's lesson. So we have here two parts. The first part here is you are going to tell whether the equation is quadratic or not, and you are going to justify your answer. Similar to what we did on our first part for the example, first set of examples. So for the second set, we have here write the formula or write the following in standard form and identify values for A, B, and C like what we did for the second set of examples. So we have here 5 items for letter B, and same, we have 5 items for letter A. So you can pause this video, copy the given, and work on it on your paper and using your paper and your pen. And just take your time and submit your answers on the agreed date with your teacher. Are we good with that? Okay. Pause this video and copy the given for both A and B. And take your time in answering. Do not forget that you need to submit your answers to your teacher on your agreed date. So what you need to remember. Quadratic equation is a polynomial equation in one variable that is expressed in the form of ax squared plus bx plus c is equal to 0, where the values of a, b, and c are real numbers such that your a is not equal to 0. Another important thing that you need to remember is, or another important point, is that equations can still be considered quadratic even if it has only two terms, if it contains the quadratic term ax squared. Like our examples, like the examples that we had earlier. So that's it. You have completed our lesson for today. Congratulations to you and see you in the next lesson.